These are the notes for Unit 10, Lesson 3. It's an extension lesson to go more in depth regarding domain and range restrictions for quadratics and square roots. Just so you know, I am recording during flex time, so there are kids in the room in case they make crazy noises. Okay, so we just have three examples that we're going to work on. Number one, it says, what is the inverse of the relation described by y equals x squared minus 1? State the domain and range of the function and its inverse. Remember, this tells us an inverse. Okay, so what we want to do is let's first go ahead and let's graph this. This is a quadratic, and because of minus 1's on the outside, we're going down 1. So I'm starting down here, and then I can use my pattern to graph. Up 1 and over 1, up 3 over 1, up 5, 3, 4, 5. And I'm doing that on both sides. Okay, so there is my quadratic. Now before we even talk about the inverse, let's kind of review this quadratic a little bit. So let's state the domain and the range. So the domain, what x values? All real numbers. Can you remember quadratics have a domain of all real numbers? And let's talk about the range now. What y values do we see? Well, the graph is graphing from when y is greater than or equal to negative 1. Okay, now let's talk about the inverse. First of all, let's write the domain and the range of the inverse. We can do that without even looking at the equation or the graph, because if you recall, the domain and the range just switch places. So if the domain of the original function is all real numbers, that means the range will be all real numbers. If the range of the original is y is greater than or equal to 1, that means the domain of the inverse will be x is greater than or equal to negative 1. Alright, so we're going to keep that in mind when we graph it. Alright, and then something else we talked about was that the inverse is a reflection over the line y equals x. Okay, which is this line right here-ish. It's got a slope of 1 and a y-intercept of 0. Sorry, I had to pause because someone's being rude. Alright, so let's go ahead and graph the inverse. So we can do it without our equation by switching the x's and y's. So the vertex of the parabola was at 0, negative 1, so that means the vertex of the inverse will be at negative 1, 0. And we can go through and just switch our points. We don't even need to know the equation. I had a point at 1, 0, and at 0, I'm sorry, at 1, 0, and negative 1, 0. So I'm going to graph at 0, negative 1, positive 1, and 0, negative 1. I have a point at 2, 4, and negative 2, 4. So I'm going to graph it 4, 1, 2, 3, 4, 2, and 4, negative 2. And then I had 3, 9, and negative 3, 9. So same idea, 9, 3, 9, negative 3. So there it is. Okay, so this inverse is made up of two square root graphs. We have the positive and the negative. We'll talk about that in just a minute. But looking at it, it is a reflection, okay, over y equals x. Do the function and its inverse represent a one-to-one relationship? No, they don't, because the inverse itself is not a function. All right, so quadratics have inverses. Everything has an inverse, but its inverse is not a true function. Okay, so quadratic will not have a true function inverse. What we can do is we can graph piece of it and get a function, and we'll do that in our next one. All right, let's go up and write the equation now. So we're going to switch the x and the y and undo everything. Add 1, and then take the square root. Now, keeping in mind, look at the picture. I have two square roots, so I do need to put a plus and minus. All right, without that, I would only graph part of it. I'm asking for the whole inverse of this original function. So I need the positive square root of x plus 1 and the negative square root of x plus 1. Now let's take a look at what happens when we restrict our domain and we only graph part of it. So this time we're graphing x squared minus 9, but only for when x is greater than or equal to 0. So that means I'm starting out down 9. 1, 2, 3, 4, 5. Let me put it right. 1, 2, 3, 4, 5, 6, 7, 8. But I'm only going to graph the right side because that's where I tell you graph. I could tell you graph wherever. Just, follow the directions. So up 1 over 1, up 3 over 1, up 5, up 7. Okay, so here's that. So the domain is x is greater than or equals 0. So even though the equation itself is a full quadratic, I'm only graphing a piece of it. So I do need to keep that in mind when stating the domain and range. It's like a piecewise. My range is y is greater than or equal to negative 9. So we can identify the domain and the range of the inverse by flip-flopping them. So the domain of my inverse will be x is greater than or equal to -9, and the range will be y is greater than or equal to 0. Okay, and we can graph that inverse by flip-flopping our points. So as opposed to 0, -9, we're going to do -9, 0. As opposed to 1, -8, we'll do -8, 1. And from here, we know it's going to be a square root, so you can either keep switching your x's and y's or use your square root pattern. That's up to you. Okay, but here's my graph. Thing goes off a smidge there, sorry. All right, also a reflection over y equals x. Okay. Now, are these one-to-one? Yes, because both the original function and the inverse are functions here, so it's a one-to-one relationship. And we could tell that from the beginning because as long as the first one passes both the vertical and the horizontal, we should have a one-to-one. So now when we go and write the equation, we switch our x and our y. So x plus 9 equals y squared. Take the square root of both sides. This time I'm not going to write plus and minus because I only graphed half of it. Which half? The positive side. All right, think about it. If I put a negative, it would be flipped and reflected over. All right, so only when I'm graphing the whole u sideways do I need the plus and minus sign. All right, so here's my equation for the inverse. All right, so now let's go the other way. I'm giving you a square root. We're graphing the inverse of that. So here's my square root, moving to the right 2. So I start at 2, and then I use my square root pattern. Okay. Keep in mind that when we graph the inverse, it'll be reflection over this line right here. All right, let's state the domain and the range. The domain is x is greater than or equal to 2. Right, so that's where that starts. Y is greater than or equal to 0. That's my range. So domain and range of my inverse, I can flip-flop those. The domain is x is greater than or equal to 0, and y is greater than or equal to 2. Right, so we can graph that by switching points. As opposed to 2, 0, I'm going 0, 2. As opposed to 3, 1, I'm going 1, 3. Right, and I can use my pattern from here. And here's its inverse. Okay, so yes, it is a reflection. Nice. So when we go and we do the equation, we switch x and y. Undo first. I'm going to undo my square root first and square both sides. And the opposite of subtracting 2 is adding 2. All right, now since the entire quadratic was not graphed, I do want to state my domain restrictions. Okay, so I want to say when x is greater than or equal to 0. Because this itself implies a whole quadratic, but we only graphed half of it for its inverse. All right, and that is all. You guys want to say goodbye?